So, thank you. So I'm giving a talk about CSS compressor, one of the modules that came out of work basically from the earlier optimization times. And it's a slightly extended version of the one that I gave at the Dutch Perl workshop this year. Who has seen that already? Okay, then there's one addition. I'm showing a bit more code and what actually happens inside of the module. Right. So let's start with the usual introduction. Who am I? Doing more than 15 years of professional Perl. And it's about compression of CSS files, which is also done in JavaScript and Java and other languages. But there was something missing in Perl. And we looked at that when I was in the optimization team, and we tried basically everything that we could. But yeah, what we tried was not possible because it was depending on Java, and well, we thought about ways on how to do it. Anyways, so what we tried to do is prepare static web resources. So before we actually put the stuff live, we try to minimize it so that we serve as little traffic as possible there, also to minimize loading times. Then we also try to do this on the fly, playing with, well, dynamic aspects in the slide sheets in order to see what we can shave off on top. Yeah, and that whole thing was supposed to be fast. And with regards to fast, how it was done before, there was a script that slurps in all the CSS files, then produces multiple versions of that, and in order to do that, it has to write all files to disk just to pass it then to the Java YUIcompressor, which will then churn through it again and split it back. And yeah, we even had to patch YUIcompressor so that it was able to take multiple files, so that was all very hacky basically. And it's overhead as well, so we're going to spawn so many JVMs that's just going to hard to get this way to it. Especially on KVMs, it's just having high impact and you being annoyed. And effectively,
what is a KVM?
Kernel virtual machine. So it's basically just a virtual machine. Anything that's going virtual and where you have the JVM, which is another VM in a VM, that's just not fun. What I could have done instead was wrapping the whole Java thing in socket access, which we did before, or I did before, but yeah, it works, but you have to maintain it as well, and you need people for that. Yeah, more dependencies in production, yeah, discuss that with your responsible manager or whatnot, who's going to decide what you can use or not in terms of resources. And of course, where's the fun back then? So, I came up with a plan. Well, of course it has to be fast, and it has to produce the very same results, otherwise it would have just been impossible to prove that it does what it's supposed to do. So I went through the source, and then the idea was to understand what's going on and effectively write some code. So what I found in the source is that it's mostly, effectively, it's completely regular expression based. So there's nothing that passes in an actual parsing way. It's really just regular expressions all over the place. The funny part there is that doing regular expressions in Java can give you a headache if you don't watch out for memory over allocation. And that's what they did. They basically went in a loop, have a new buffer here, put stuff in, and then run a regular expression over it, and yeah, you get the idea. And then they had a lot of tests. That was a good thing. So it was rather easy to get started with something. And yeah, so I started hacking it with the tests from upstream and a few more thousand tests from production. And yeah, I went into the regular expressions to see what to get out of it. Like, I mean, it's Perl in the end, so regular expressions are supposed to be powerful there. And yeah, in that regard, executing Perl code and regular expressions can help a lot. So, how does it work? That is the new part of the talk now. First, it just goes through the whole CSS, collects all the tokens and comments, and just puts them aside in order to investigate them. And then there are some special comments where you can say, well, I want this comment to be preserved, so it's pulling those back. After the cleanup to make sure that nothing that's legitimate is removed, it mutes everything else that's not needed anymore. And in the end, it just puts the things back that you actually want in the output, trim a bit, and that's it already. So, step one with regards to collecting all the things out of the CSS that you might want. So this is the part where the execution of code comes in. So I profiled that for quite some time, so that's why it's rather compact. But the fun part is that I'm basically using everything that I can from Perl in order to make it fast. So pushing within the regular expression and then adding that to -1 just to make sure that I get the proper offset and things like that. Then to put the comments back, similar horrible regular expression you could say, because I'm doing regular expression in regular expression. Try to do that in Perl, in Java I mean. Yeah, it just keeps going in that style to put in markers so that you can afterwards go over them and put them back.
I'm pretty sure 5.8 will crash on that.
Yes. And 5.14 as well, I think.
No, definitely not.
Huh?
But
Okay.
does it use like the
I would know from Pentesters.
Okay.
So the compression part is, well, it's a lot of those kind of rules where it's like, yeah, okay, there's content, something's not needed, 0 pixel, well, that can just be 0, 4 zeros can be 1 0. Yeah, it's all along those lines. And once that is done, it's just going to put the things back. So this contains what we previously collected in the push. And that's it already. So there's only space left in the beginning and the end. And then you have the result. Performance comparison, yeah, I'm not going to talk about JVM start times. Runtime performance improved by 50%. Anyways, before it was, running over almost 1,000 files in 40 seconds. And then the improvement is more than 50%.
Why do you have, like, is that a typo, compressing 490?
Oh, thank you. Good point. It's because it's not 1,000 files, it's actually just, almost 500. Because the YUIcompressor deals with JavaScript and CSS. But the JavaScript parts are completely different, so I wasn't able to port that in a similar way.
Okay.
Even though I'm still dreaming of it, but
Either way, you're not optimizing JavaScript.
no.
Okay.
You guys should check out Chrome. It does all that stupid junk
I know,
for most companies.
but I wanted to port.
Yes, but so you check out Grunt, see what they're doing, and especially since they started with JavaScript, before they started doing all the other files, like a copy, just like what you did here.
I read the source of the YUIcompressor multiple times, and I still want to do that. With regards to performance comparison, we have no comparison for the dynamic style sheets. I have never seen anyone else doing that. Then you could still ask, why did we do that? Well, we know that YUIcompressor works, so we basically didn't have to invent anything new. Then you have unit tests. Awesome. How do your customers like those? Then the correct results, again related to production data and what we have already. And we can put it everywhere because we use Perl almost everywhere. And that also counts for, oh, I have that on the next slide. Yeah, it would be faster in C, of course. There are even modules on cPanel, but I checked them long ago, and they weren't doing exactly what we're looking for. Yeah, and that is the point that I wanted to get to, is because it's working in pure Perl, it just works everywhere. So if you have your, don't know, shared hosting provider, it will just work. Yeah, and it's easy to change and integrate, exactly. That is also what allowed a rather smooth transition into production, because we could just run it aside with the existing stuff. And the results, if anything, showed differences were just being made back. So that was running a few weeks in the background. And then we changed it to be more active. And yeah, still got the mails if anything failed, and there were very few things that came back. And yeah, since that was successful, we turned it on in production, and since then we run it. Except for dynamic style sheets, which is very simple with the whole thing, because it's just one function that you call and you get what you want. But the story there was that it actually didn't show any return of investment, basically. Back then we weren't big enough to make it worth it. Maybe we could retry that, but it was not worth maintaining the infrastructure, and yeah. But what we still use is basically everything non-dynamic. So static compression everywhere is using this one. Yeah, at some point I wrote a blog post that also made it to Hacker News for a day, Reddit and stuff, and even completely unrelated online news, as I found out afterwards, which I found quite funny. Was a management something magazine, so they talk about Perl. That's also good to know. Comments on Twitter as well, but that still wasn't enough for me, because I wanted to use it also. I mean, it's nice that you have a module, but being able to throw it in, that would be interesting. That's what I wanted. Pipe? Anyone? Mojo, for example, those at least were the ones that I looked at first. For Pipe, was actually rather fun to write, because it's reusing the static middleware, and the code itself is very, very little. And this is how you can enable it. Yeah, just a typical enable my flag middleware, specify which suffix you want to have. That's pretty much it. Similar for Mojo, just load your plugin, specify which suffix you want, so you can also put something else. Some people use -min, some use .min. Any standard on that? Anyways. Yeah, the Mojo case. Then somebody else also wrote a Dizilla plugin, which I found cool, because that just means if you want to compress your files at distribution time, just throw this little thing in and you're done. It will just go over all your CSS files and compress them. Right. So, that is pretty much it. Any questions, complaints?
Why aren't the dynamic CSS provided with a flag middleware? Because you already showed that it's possible.
Sorry?
You could serve dynamic CSS using the flag middleware.
Yes. But there was more logic behind it. Like, well, one of the issues with CSS is that it always, like, as sub request sends referrals. So if you have really huge URLs, you can multiply traffic, and that, I guess, is what happened in our case. Yeah.
Have you considered creating gzip versions of the files and just
yes, of course,
serving directly?
Next step.
Okay.
So both.
Okay.
This minification plus gzip.
Okay.
Why not fully parse the CSS?
That was my question.
What Leon said.
Yeah.
Because the parser could find all the overrides, because you mentioned in the other talk, like what if somebody makes a statement up here and later on they override it down here. And
right.
I said, well, there's something like Destiny selectors, but actually a parser would do the same thing. The parser only gets one end set of rules, and you could say, okay, parser, what do you see? And
That is true. Given that I still want to look into JavaScript and the tool that I want to use for that, I might even give a talk about MAPA at some point, but that's a whole different story. But yes, parsing it properly could
steal
be.
someone's parser, but then choose carefully whose you steal.
The biggest problem of having your parser is that probably you want like a headless browser together with that to parse it properly. So you don't need only a parser because he wrote a parser. What you want is something that can actually read the CSS, understand the rules, all the CSS3 bullshit, then get the result of that and then create something. So it's a little bit more than having a parser.
Yeah.
Isn't that what the parser does, though?
The parser gets the file, transforms that into a string, and then creates a representation of that. This is a parser. What you're talking about is more like something like a browser that gets that, parses that, interprets that, and then does something with that according to the CSS rules.
You mean like the painting and the...
Yeah, so it's a little bit more than that. So that's actually a parser.
Yeah, well, and the point would be that you could, if you have it all parsed properly and you have syntax trees, you could actually go into the semantics and then clean rules up, remove those that would never show and so on.
But then we have dynamic stuff that depends on, like ES6, you have these overrides that you can't remove from the code. Because
There are some special cases in the code dealing with those. And yeah, that's the result that you, well, for the proper parsing.
Yeah.
Yeah, so you basically would have to implement the very same rules there to make sure that it doesn't break those.
Did you ever consider deduping? Like if you have in one set of style sheets that is loaded, you have the same tags, it's CSS, so you can have as many as you want, that you detect it's overloading the same thing and just remove it from the first.
Yeah, then
Well,
you need to
yeah,
parse
parse,
it.
Yeah.
You need to parse it.
Yeah, but
Yeah,
that
once you
might
parse
be a
it-
huge win in compressing.
Yeah, but once you have the parser, you can have optimization there, like you probably parse it and then you have an optimized default.
Like I said, the parser only has one set of rules that at the end of all the cascade is just, okay, these are the set of rules for that element. Reads it once and then step one, it doesn't keep all the others.
You want to parse it into some kind of abstract syntax tree and then do something smart.
Yeah.
I'm not going to mention the Perl 6 word here.
What would you do? They're not running Perl 6 here.
Awesome.
Not yet?
Then thank you for your time.